let's freaking do this. Antidepressants, history, mechanisms, ketamine. um, I feel like at this point in the year of our Lord 2024, most of us have come across these in one respect or another. So, I'm hoping that the bulk of what I'm going to talk about is shit you've never freaking heard before in your life. Um, and I'm excited by that prospect. Uh, everyone knows though. Everyone knows already that antidepressants are a therapeutic class of drugs, and they treat a lot of different things besides just depression, both mental and physical disorders. They're mostly designed to treat depression, of course, and depression can actually be considered both a symptom and a diagnosis. And plot twist, antidepressants can be prescribed to treat both of those things. Because in either case, the things that antidepressants are trying to treat, it's the same in both of those gosh darn things. But first, I always have to do this first. Trigger warning. I'm gonna have to talk about some messed up things involving mental health, particularly suicide. You know, the worst thing ever. It won't be terribly graphic. It will be very scientific, I promise. And it may also spawn discussions about suicide, which I do encourage to an extent, but just know that that's going to be part of the subject matter tonight. And I'll give slight warnings here and there about it. Oh yeah, I was actually going to ping. I think this is just in the US, but I was just going to pin the crisis hotline just as a reminder and a resource in case it is needed. So yeah, those subjects are going to come up, and I'm sorry about it. The other thing is a little disclaimer. I'm not a doctor. I'm a scientist, so I can't I'm not here to condemn or promote any of these drugs. I just like molecules. I'm here to tell you about their molecular mechanisms. I'm not here to propagandize about them. And I would prefer that no one else propagandize about them either. Again, I encourage discussion about them, but if, for example, you tried Prozac and it was the worst experience ever for you, you don't need to convince others to avoid that drug and to avoid getting help. I really don't I don't really want to see any of that because everyone is different and I would rather not discourage people from getting any kind of help that they need. So again, share your experience, but just don't propagandize, and I promise not to either. This is a picture of me and a bull testicle. Uh, you know, classic science things. Classic molecular biologist things. Um, so yeah, this is gonna be fun. Tonight we're basically gonna take a journey through the history of antidepressants from their humble beginnings as tuberculosis drugs to their current and interesting delve into some fun hallucinogenic and dissociative drugs. Uh, like PCP, which is what's pictured here on the left. That is PCP. We're no. Oh, but not small. You know, it's not the size that matters. Look at all those rings. Well, you are correct about that. It is not complex at all. Exactly, pina colada precipitation. That is the full scientific name for PCP. Okay. All right. Hi, Hamster. I'm sorry you had to hop in and hear that. Thank you. Have a wonderful night away from all the PCP. That's why people get addicted to it. Because pina coladas are delicious. But yes, so you know right out the gate that some of these drugs have some fun roots. It was absolutely something that you didn't want to hear, and it does not bear repeating. Something about sucking pina colada out of her shirt. I don't even know. So I'm gonna take you in my Miss Frizzle time machine bus, and we're gonna take a somewhat chronological look at antidepressants. I'll give some examples from each of the classes, and although there are a lot of similarities between them, they are antidepressants. They do treat depression. I'll be explaining their different side effects, mechanisms of action, and indicated diseases. And along the way, we'll learn some ideas about how the causes of depression have evolved over time, and how those ideas have shaped the development of this diverse class of medications. So what do they treat? Major depressive disorder, MDD, is obviously the big one. That is generally what antidepressants will get prescribed for. It's considered a mood disorder, much like bipolar disorder, but is characterized mainly by just those depressive episodes. Also, anxiety and panic disorder can sometimes be treated with antidepressants. OCD as well, I would say that is anxiety adjacent. ADHD sometimes can be treated, as well as some eating disorders, particularly bulimia. Some of them can help you stop smoking cigarettes. And then we got some pain disorders that can also be treated with antidepressants. Neuropathic pain, whether from diabetes or other types of damage, or fibromyalgia. There's a couple other things. PMDD, premenstrual dysmorphic disorder, which is characterized by mad depression. Bipolar depression. Bipolar has mania and depression, and sometimes those depressive episodes can be treated with an antidepressant. Migraines can even be treated, as well as insomnia and narcolepsy and priapism, which is when you have a boner for too long. So this is a pretty diverse set of things that antidepressants can treat. A lot of times I would say some of these things just kind of make you depressed, and that could be one of the reasons why there would be an off-label prescription for an antidepressant. But the major thing is major depressive disorder. So I want to look at why doctors, I have so many notes. We're going to take a look at why doctors will prescribe these medications. Obviously, it's more than just the name. It's all of the things that go into the disorder. So we're going to go a little more in depth into the diagnostic criteria for MDD. Please don't diagnose yourself with major depressive disorder just based on this one slide that I have right here. If you have feelings, you should do your own research and put some time into it. And this is just from the DSM. There's other diagnostic tools besides this. I chose it because the study that I read broke it down really well for a not psychiatrist, psychologist person. It's not because I think it's better or anything like that, because I wouldn't know because I'm not a doctor. Anyway, the diagnostic criteria for MDD, we're going to go through it really quick because, again, I want you to understand what exactly is going through doctors' heads when they're choosing these different medications. So in order to be diagnosed with MDD, you absolutely must have a depressed mood, as well as loss of interest or pleasure in things that you used to like. This is called anhedonia. So you have to have depressed mood and anhedonia every single day pretty much for at least 2 weeks. And then holy crap. And then randomly they put weight change right here. You'll see why that's random, because 4 through 8, which is not sleeping at all or sleeping too much, being restless or not wanting to ever move again, being tired, feeling worthless, and impairments in concentration. All of these things also must be present for that amount of time of 2 weeks. And, the disease varies from person to person. So like I said, the first 2 definitely have to be there. And then, is it 4 through 8? Just making sure I was right. So the depressed mood along with criteria 4 through 8 have to be there. And then this last one is suicidal ideation. Significant weight change and suicidal ideation are just kinda, they're aspects of the disease, but they're not required for, I'm so sorry. Oh my god. They're not required for diagnosis. There we go. Yeah. I don't know why I thought it was weird that they listed it like this. I don't know. I'm not a doctor. Maybe I don't know why. I feel like I would group these differently, but whatever. Then there's the other criteria. Your symptoms must impair your social or occupational function. So that might look like withdrawing from your friends, or maybe behaving in unsavory ways toward them as a result of your depression. In terms of occupational function, maybe this is impairing your performance at work, or maybe you're having to miss more work as a result of your depression. For criterion C, your symptoms is a diagnosis of exclusion. It can't be from substance abuse, because that would be something else. That would be something different than MDD. And your symptoms, of course, can't be from another mental disorder, because again, it wouldn't be MDD. So these are the things that doctors are going to be looking at when prescribing antidepressants. And they're certainly going to be paying a lot of attention to these different symptoms on the left when it comes to choosing an antidepressant, because they have different effects and they have different side effects. So, the central goal of prescribing a antidepressant is mood elevation. That's really the main thing. A good mood is like the only ingredient you need. Not the only, but it's the main ingredient behind success. Whatever success looks like for you, a good mood is gonna do a lot for you. So, and people who have MDD, it's not just that they are in a bad mood, it's that their mood is disordered. And there's a difference, because having a disordered mood can significantly impact your quality of life, which is why elevating it and making it more regular is the top priority when it comes to antidepressants. Because obviously, a good mood, an elevated mood, can alleviate some of these symptoms. It'll make you sleep better, and it can make you concentrate better, and your thinking in general will be less negative. Again, recipe for success. Even so, the cause of depression, not just in individual people, but molecularly, tends to be pretty elusive. So it's yeah, it's really important to consider all the symptoms. These are other even though MDD is the main thing that we prescribe antidepressants for, these are close enough depressive sort of disorders that will very, very commonly get prescribed antidepressants. Yeah, good mood is, I mean, that might seem dramatic, but honestly, A good mood is the only thing that you need for success. So in understanding what causes MDD, and this is actually why I just chose MDD, not just because it is what we mainly prescribe antidepressants for, but because if I had decided to look at a lot of other diseases, they all have their own circle. They might all have even more slices of pie than this guy right here. Uh, but and they're all true. Adrenal, HPA axis dysfunction, weird hormones, stress, traumatic events, genes. Obviously, all of these can play a role in the development of major depressive disorder, but I just care about these two. This is literally all I care about. The monoamine hypothesis and the structural and functional brain remodeling hypothesis, which I'm going to refer to as the neurotrophic neuroplastic hypothesis. But the monoamine hypothesis, that's the first draft, really, for all of this. That set of ideas is what spurred the development of more of antidepressants in the first place. And it came about during the 1950s, which was an amazing time for biology. We were figuring out the structure of DNA. We really liked LSD, and we liked to do a lot of studies with LSD. And we were starting to put together what makes people sad from inside of their heads. Reserpine, not an antidepressant, quite the opposite. Pardon me? Reserpine really jump-started our foray into antidepressants. It comes from devil's pepper, and it was initially being used as an antihypertensive agent. And studies in the 50s showed that people taking this medication got really sad. They got really depressed. And this study here from 1956 demonstrates, on the left, this study had 296 people. There was a group that wasn't taking any of the, Rauwolfia, which is the devil pepper. There were people taking the plant, there were people taking, specifically the reserpine from the plant, and then there were people taking another concoction from it. And the study noted that a good chunk of people taking the plant, particularly the people taking the purified reserpine, reported depression. And from, there were other studies reported. This study from 1959 kind of confirms that same thing where people taking the reserpine concoction experienced depression at a way higher frequency than people not getting any treatment, so maybe receiving a placebo. And they even got depressed more often than people taking the reserpine with something else in conjunction to help lower the blood pressure. So, oh yeah, I guess I felt the need to put that. A lot of these studies, they kind of reflect trends that are still true today. For example, women are apparently twice as likely to experience depression. I think that could potentially be seen as women being twice as likely to report depressive symptoms versus men. But this same study from 1959 showed that women were still predisposed to depressive symptoms, and there is this 2023 claim from the World Health Organization that apparently 6% of adult women and 4% of adult men experience depression. Another common sort of trend is, of course, if you already have a history of mental health problems, then the reserpine was probably going to make you depressed. And that's sort of true today as well, even with antidepressants. If you have a history of feeling depressed, you're gonna feel depressed on this drug that's meant to make you depressed. Um, but what the hell is going on here? Why is this blood pressure medication making people depressed? Well, that involves the birth of the monoamine hypothesis. So, monoamines, we know them so well. We love them. Norepinephrine, dopamine, and serotonin are all monoamines. You literally love them. Or rather,
Well, technically, it would be more accurate to say that they tell you what you love, but
yes, we literally love them. They're called monoamines because they have one amine group. Look at them. Look at how beautiful they are. There are probably more, but these are the cool ones that we care about. They are all present in separate concentrations between the brain and the body, and they have distinct functions in those areas. I'm so offended, Ender. I cannot believe you. How could you backslash me? Yeah, get out of here, spammer. Yeah, so norepinephrine is a sort of target for antihypertensive drugs because it's involved with sympathetic control. Norepinephrine, its function is mainly to increase heart rate and increase vasoconstriction or constriction of our blood vessels. So obviously that makes it a target for hypertensive drugs. Our fight or flight controller. In people who have chronically high blood pressure, they obviously don't want that. So naturally, since reserpine was found to lower norepinephrine, it was used for that purpose. However, you spammer! Is it a backslash or a forward slash? I actually don't know the difference. So, that's good. Having reserpine lower norepinephrine, so really good for lowering blood pressure. However, reserpine doesn't discriminate. It depletes the other monoamines as well. It prevents these neurotransmitters from being nice, neatly packaged into vesicles, which protect them from the harsh environment of the cytoplasm inside the cell. And once they get packaged into vesicles, they can then be released into the synapses to, do their jobs. If the neurotransmitters, if these monoamines are being prevented from entering the vesicles, then they just sort of hang out in the dangerous cytoplasm where they can get degraded by an enzyme called monoamine oxidase. Not your cytoplasm, your dangerous cytoplasm. This enzyme also does not discriminate. It just breaks down all the monoamines. It doesn't give a shit. And so when researchers
Oh yeah! This is happening!
Resub! Hell yeah. Thanks, Bow. Hi, Bow. Sounds good. Have a good time out. Oh, I bought a farming game recently. I want to talk to you. But have a good night. Okay. So this is kind of how these researchers put two and two together. So monoamine oxidase, it breaks down all these guys. It breaks all of them down, which means that there's no neurotransmitter left to be released into the synapse, and then there's nothing to do their jobs. And monoamines have very, very, very important jobs, as we will see. So the fact that reserpine was causing these depressive symptoms, and that these people had, a lot less serotonin than normal, and a lot of serotonin metabolites, indicating that the serotonin was being broken down at a higher rate. That's when they were like, "Oh my god, monoamine depletion causes depression." Boom, mic drop. Uh this was just really so serious at the time. 'Cause I don't know, think about mental health in the 50s. Just think about what was going on at the time. So, this was huge. Figuring out that, oh, if this drug depletes monoamines and makes people depressed, what if we did the opposite of that to make people happy? Uh, and that's sort of, you know, again, it was less deliberate. This was another just kind of like, oh, we figured this out by accident. Uh, but something that ended up making researchers lustful still for this monoamine hypothesis was the effects of this random tuberculosis drug. Weirdly enough, this drug, isoniazid, it went on the market to treat tuberculosis in like 1952 and 1953, and it worked super, super well. But there was still motivation out there to continue researching, continue finding things that could help still treat tuberculosis. Um, and as you can see, based on this info from the World Health Organization, uh, tuberculosis really obviously declined a lot when this drug was discovered. Um, and yes, okay, 1952, that was when, they keep researching, and they accidentally on purpose make another tuberculosis agent called iproniazid. It's different in better but different ways, I guess. Um, this clinical trials for this drug was like the opposite of reserpine. The researchers noted that like, wow, these people sure are happy. What could possibly be going on here? Uh, I mean, they had elevated moods, and then they had other sort of effects as well, increased appetite, and their sleep was improved as well. All of these interesting, how you say, antidepressant effects. Need to move this one. Um, so this is the first antidepressant, unceremoniously announcing right now. This is the first one. And it will serve as our example for the first class of antidepressant, which is the monoamine oxidase inhibitors. As you can tell by the name, they inhibit the enzyme monoamine oxidase, which remember, those normally break down serotonin, norepinephrine, and dopamine. Um, so because we super figured out that monoamine depletion causes depression, this was sort of an effort to reverse that effect. Um, Monoamine oxidase has two isozymes, two little forms of the enzyme. Um, Excitarad. How why would they make fun of you for that? They're so rude. Well, great. Did you know that you have the best way of talking so they can get fucked? It means horny. Okay, I guess colloquially. In English, I guess in English we have that too when someone's excited. You could see that as being horny. Which is funny because no joke, we're talking about erections later, we're talking about horniness later. We're talking about excitadad. That's so funny. I would never make fun of you, I love the way you talk, Gray. Um We speak it literal. Exactly. These losers. That's their way of talking is just really, really boring. So anything outside their boring talk is worth making fun of, I guess. But now I'm just gonna have that word in my head. Oh, you're good. These are these are my favorite interruptions. But yes, my MAOIs, my MAOIs. Two different forms. MAOA breaks down the big players. Norepinephrine, epinephrine, dopamine, and serotonin. And melatonin. Can't forget melatonin. And then the other one breaks down also dopamine, as well as tyramine and other trace amines. Now, it may not seem like those are as important, but they're pretty important, especially when it comes to one of the side effects. But in any case, the idea with iproniazid is that we inhibit the breakdown of these monoamines, and it makes people happy. Exercise causes endorphins. Endorphins make you happy. Happy people just don't kill their husbands. They just don't. It's oh my god. It's just this simple. But here's the problem. MAOIs are not really marketed today because they cause this thing called cheese crisis.
What?
It's not funny. It's bad. So, cheese and other fermented foods like beer and like soy, stuff like that, they have high amounts of tyramine. And if you are inhibiting MAO and you are not efficiently breaking down any tyramine that enters your body, then this can cause really, really dangerous side effects, like hypertensive crisis. And yeah, I think that's the main one. Oh yeah, and migraines, which also sucks. So because of that, because of the cheese crisis, we don't really market it today. I think other countries might still use it, but in the US, it's really uncommon for MAOIs to be prescribed. Having the cheese crisis right now. Dude, my cheese crisis is just when I don't have enough cheese. That's my cheese crisis. I am the hypertensive crisis. Oh no, Gray. So never go on MAOIs then. Never ever. That would be bad. But yeah, there are efforts to make so these are these ones that cause the crisis are irreversible MAOIs. So they bind and inhibit the enzyme and then they are married forever and they just stay like that. So there's some development in reversible MAOIs where they bind the enzyme, they inactivate it, but then they eventually dissociate so that at some point the enzyme can kind of reactivate. So it's more not as inhibitory as it is sort of regulatory. But I don't think the US has approved any of those yet. Cheese makes me excited. Exactly. I can feel it. I can feel it in my nuggets right now. Oh my god. So yeah, MAOIs, meh. We're so over them. The next class to be made was tricyclic antidepressants or TCAs. They were isolated from antihistamines. And I'm ahead of myself. I'm just so excited about antihistamines. They're called tricyclic antidepressants because, gee, could it be because of these 3 circles? It could be because of that. It is because of that.
Welcome to my 3-ring circus.
Welcome to my 3-ring circus. Interestingly, TCAs are the class is named for their chemical structure rather than their mechanism of action, like MAOI. It's named for what it does. Same with SSRIs, which we'll talk about later. The class of drug is named for what the mechanism is, but these guys, it's the structure. It's all about the structure. Oh, it is? Heck yeah. That makes sense because I think also other anxiety meds, benzos, are isolated from antihistamines. Atarax. Ooh. Wait, I'm gonna look that up right now. I want to see what the chemical name is because I've actually never heard of that.
Atarax sounds awesome.
It does. It kind of, yeah, that is what it sounds like. Oh my god, yeah, literally, it's hydroxyzine. Yeah, okay. So cool. Yes, so that is the interesting thing about the fact that this is from an antihistamine is a lot of them are not only are they used for anti-anxiety, but their derivatives are used for anti-anxiety, and there was another drug also discovered at this time that was derived from an antihistamine, and we're gonna see why that fact is important to its mechanism. But this imipramine which came from the antihistamine, oh my god, promethazine. It came from promethazine. It was created in 1951, and specifically comes from a first generation antihistamine. That's important. First generation antihistamine. First generation antihistamines make you tired, like Benadryl. Benadryl. The itchy, the itchy, itchy, the itchy, the scratchy, itchy. And they're called first generation because second generation doesn't make you sleepy, because they're peripheral. You could take Allegra and you're not going to fall asleep because it doesn't go into your brain and act as an antihistamine. In any case, freaking researchers at this time were so just riding the high from discovering the first antipsychotic as well. Chlorpromazine. Just, look at that. Wow. It's so tricyclic. This was really good news for anyone concerned about other antipsychotic techniques at the time, like shock therapy, or insulin shock therapy, or just fucking brain surgery. Like, this was a really huge thing, and it was very effective for schizophrenia, and it led to the development of a new drug class. More antipsychotics obviously were developed as a result of this. And we really wanted to keep this kind of hype train going. Like, it was so effective for these mental disorders. And imipramine was then developed slightly after this antipsychotic, but when they tried it on people with schizophrenia, it didn't really do much. It didn't do much for the symptoms of schizophrenia, but it did have antidepressant effects, which was very exciting. But we don't use it as much anymore because we have better TCAs and honestly better classes of antidepressants that are more effective. So my example is going to be the most prescribed TCA in the US, amitriptyline. I don't know how to pronounce any of these, by the way. I don't know if you guys know this. I have no idea how to pronounce them. That is your name, yeah. Amitriptyline. Actually, in molecular biology, you can honestly just pronounce things however you want. So maybe I'll just call it amitriptyline. It's way funnier. Do you when you're on mushrooms? Oh my god. Amy on mushrooms is Amy Triptyline. Oh my god. Oh, for most of them, but not amitriptyline, funny enough. Oh my god, will it come to me? Imipramine, I for sure have no idea because it's so old, I just, like, didn't even bother. When we get to the other drug classes, I will remember them, and I did list next to some of them, but of course, just not amitriptyline, but I'll amitriptyline. I'm faster. Or maybe I'm not. Oh yeah, don't forget to type wiki every time you Elavil? Oh, Elavil. Yes, thank you. Amy is spelling it. Thank you, Amy. Yeah, for the most part, for the rest of it, I do have the brand names listed, and if I don't, I will either remember it and I will say it, or I'll find it. Elavil.
Evil.
Some of the newer antidepressants have the most. You'll see what these are. But yes, amitriptyline, aka Elavil. Every villain is lemons. It not only treats depression, but also neuropathic pain and fibromyalgia, as well as migraines and sleep issues. Some of those might be clear right off the bat, like why they might treat those things. But we're gonna see why, in general, TCAs tend to be kind of first-line treatment for things like fibromyalgia. So amitriptyline, along with other TCAs, they increase the amount of both serotonin and norepinephrine hanging out in the synaptic cleft. And they do that by blocking the activity of those transporters. SERT is the serotonin transporter, and NET is the norepinephrine transporter. So by blocking those transporters, we are effectively blocking the reuptake of those neurotransmitters and keeping them where they're gonna fulfill their actions. And again, that monoamine hypothesis, having the monoamines with their sustained action has antidepressant effects. So that's some more evidence for that monoamine hypothesis. This drug, though, doesn't just act at the transporters. It has affinity at some receptors as well. And that's sort of going to explain their side effect profile as well as why they treat things besides depression. So what we're looking at here, this is amitriptyline, and this is its metabolite. And it's important to note that a lot of times when you take a drug, it obviously is going to get metabolized. It's going to be broken down into other molecules, and sometimes those molecules can have some pretty profound effects on you too. So, these numbers right here, these are dissociation constants. It is basically the amount of the drug needed in order to occupy a certain amount of receptors at a given density. So the lower the number, the higher the affinity the drug has for the receptor. So right here, 3.13, this is nanomolar. That's a pretty high affinity. So amitriptyline really likes the serotonin transporter. And over here, it lets us know that it inhibits the transporter. It also has a very high affinity for the histamine receptor, which makes sense. It is derived from an antihistamine. So it binds this receptor with high affinity, blocks it, and that is what gives us the those very sedating effects, those anti-anxiety effects, often associated with histamine blockers. Yeah, that's all. I think I already mentioned first generation antihistamine. So, you know, we solve sleep. Sleep has been solved. Another receptor that amitriptyline has a pretty decent affinity for is the 5-HT2A receptor, and it blocks it. The 5-HT2A receptor is a really kind of a hot ticket item when it comes to this kind of research. It is expressed in brain areas involved in learning and memory, and emotion, and it famously causes hallucinations when activated by certain psychedelics. Well, by psychedelics. When hallucinations and other psychotic symptoms are present without the use of psychedelics, that is when a doctor might prescribe an antipsychotic. And most of those meds will actually block serotonin action at 5-HT2A. So, even though TCAs though are really similar to antipsychotics, especially in this respect, in the serotonin blocking respect, they are distinct because antipsychotics actually focus a lot more on dopamine blockade. When you come, do you get a blast of serotonin or dopamine? You get a blast of there are different phases of orgasm. So serotonin. And here's why. When you're like building, that's, you know, dopamine is being released because it's sort of, you know, more associated with pleasure and reward. But then at orgasm, I think, that's when serotonin more gets released in a regulatory sense because it's like, all right, enough with the dopamine. And serotonin actually gets released in a burst to decrease dopamine. Literally, yeah. I got you. I thought it I also initially imagined, like, physically getting blasted with either of those neurotransmitters. Um, but yeah, that's loosely I mean, there's so much that goes on in your brain, it's probably more complicated
Guys,
than
I'm
that.
enjoying a crisp Diet Cock. I mean Diet Cock. I mean Diet
But
Cock. I mean Diet Cock. I mean Diet Cock.
loosely, that's what's going on. It works the same way with hunger because, I think I'm probably gonna say this later, but I'll say it now anyway because it's super relevant. Dopamine tells you that you want to eat, you know? It tells you like, "Hey, you're hungry and you would like that food over there." And then once you start eating the food, like while you are actively consuming the food, serotonin gets released, and when it binds specific receptors, it lowers dopamine and promotes feelings of like full of satiety and lowers your appetite. If you're hungry for Diet Cock, then your entire brain is gonna just turn into like an ocean of just serotonin and dopamine, probably. You're gonna drown. Oh my god. Um. So yeah, 5-H2A is it's pretty heavily involved in those things. And you know, this kind of shows, I think it's confusing sometimes to people, the fact that, you know, certain meds that are supposed to promote antidepression block serotonin receptors. Um, and we're gonna see a lot more of that later, but I'll tell you right now that, regulation is really the key here. It's not good to have, you know, too much serotonin in any part of your brain probably. You want the right amount of all the neurotransmitters and not too much or too little. Um, and, oh shit. Um, and that's really, you know, that's really key here. Um, which is why the blockade of the specific serotonin receptor is actually antidepressive. Um, and I have to mention something, a little messed up here just for, talk about this specific receptor. So I'm sorry, but, uh, in autopsies of people who have completed suicide, they have increased, like, a lot increased amounts of these receptors in not just their brain, but also, in their platelets, which is relevant because platelets help take serotonin out of your blood. Um, yeah. And, uh, so, yeah, clearly this receptor is really important for monoamine, regulation in a way that might not fully be understood, but, um, the fact that there are more of them in, people who have experienced depression to its most extreme degree, uh, tells me that there's a lot of, maybe maladaptive mechanisms going on, some compensatory things going on. Um, but anyway, depression solved. Oh yeah. All this stuff really depends, like, there's so much going on. It really depends on, like, how many receptors and their density, where those receptors are, what types of circuits those receptors interact with, and just how their distribution is. It really, there's so many things going on. Well, luckily, we haven't got SSRIs are next, so we'll see, you know. This will be a challenge. Can I get you to understand SSRIs? I can fix him. We'll see. I hope I have a good way of explaining it. But once we get to it, I would be curious what you don't understand about it. But also, I don't know. There's just so many up down things. Like so many different things that affect other things. It's just stupid. Uh but yes, we've solved depression. There we go. Amitriptyline has solved depression for us. But now we're going to look at pain. Uh so pain can be divided into three categories. We have neuropathic pain, which comes from direct damage to nerves. We have is it inflammatory? No, so that's neuropathic. We have nociceptive pain, which comes from tissue damage. So that's just like if you cut yourself and it hurts. That's nociceptive pain. Um, and then we have the very esoteric nociplastic pain, which is the type of pain that people with fibromyalgia tend to experience. And that is when there's like a literal just problem with the circuitry in the central nervous system, which causes a hypersensitivity to the feeling of pain, even if it's not there, or even if there's nothing that's outwardly causing the pain. Um, and that's why it tends to be so difficult to deal with because it's the intrinsic circuitry is what's messed up. So the reason TCAs are good treatment options for pain is what we're going to go into. This is a schematic. This is pain right here. You receive some sort of ouch, and that information about the ouch, information about the pain travels up your spinal cord and goes into these integrating centers in your brain. That's the ascending pathway. In the descending pathway, we have this literally to help attenuate pain so that we can keep functioning. It's like a survival thing. So in the descending pathway, that signal it's getting after it gets processed, it travels back down your spinal cord, and it leads to the production of endogenous opioids and other things that are going to lessen the pain. Again, for survival. They produce analgesia, which is pain relief. Norepinephrine is the big guy here, and to a lesser extent, so is serotonin. But it's mostly norepinephrine that will bind its alpha-2 receptor to prevent further activation of the pain pathway. It literally this inhibits the pain pathway basically. So remember that amitriptyline has this super fun metabolite. And this metabolite preferentially binds the norepinephrine transporter. So, this eventual inhibition of norepinephrine reuptake is likely what is helping treat pain, because this means that you have more norepinephrine hanging around, and therefore more norepinephrine to activate alpha-2 adrenoreceptors to decrease pain. If your spine is curvy, it's just gonna take, like, a really long time for the, pain signal to travel to your brain, so you'll have this sort of delayed perception, and 15 minutes after you cut yourself cutting onions, you're gonna be like, "Ah! Ow!" Just gonna be really, really delayed, you know? Oh my god. So pain solved. Easy peasy. This, we're so obsessed with serotonin, but we just cannot ever forget these other players, because it is the reuptake inhibition of norepinephrine here that is helping with the neuropathic pain. Exactly, yeah, this is why they do it. They just wanna weed out who the weaklings are. The straight spine people, they have too much pain perception and it makes them pussies. So they gotta see. Um So yeah, TCAs they're clearly very versatile in what they treat. But when it comes to good old classic depression, another class gets way more prescribed in the US. No one doesn't know what an SSRI is, I feel. Everyone knows Prozac, which is fluoxetine. I mean they're the top two antidepressants described in the US are SSRIs. And of course, Prozac is actually not number one. I think Zoloft or sertraline is number one. But in any case, Prozac is obviously going to be my example. Uh, so SSRIs, we're in the 1960s now. We are so obsessed with serotonin. I mean, we're just obsessed. So this is when the first SSRI Prozac was developed, and it took a lot of years to actually get approved. It didn't actually get approved until 1988. And to this day, it is one of the most prescribed antidepressants in the US. And like I said, the other two, the two actual most prescribed antidepressants are SSRIs. Um, they pretty much all do the same thing. They selectively block serotonin reuptake. What? Yeah, they all work really similarly. They have slight differences that we're gonna see, but they're all pretty. Why do they not let some people Kumis? I'm gonna go so in depth for that, Greg. Get ready. It's gonna be great. Mrs. Tonin. Speaking of Kumis, you can see here that Prozac has a super huge hard-on for CERT, for the serotonin transporter. So that monoamine hypothesis, the obsession with serotonin. If we block its reuptake and we keep it in the synapse where it's going to be active, we're going to have antidepressant effects. And it really doesn't have, remember, the high numbers indicate low affinity. I mean, it kind of for H5HT1A, but really there's not much activity at any other receptor. We have other SSRIs that also focus a lot on CERT, and I actually think have more affinity. So Lexapro or escitalopram, I would say, yeah, higher affinity for CERT. Literally nothing else, though. The most monogamous SSRI in the world. It doesn't do jack. It only inhibits serotonin reuptake at CERT. If you're only affecting serotonin reuptake, then there's not much regulation with serotonin itself, because in reality, some of the receptors that serotonin binds, they have serotonin is an inhibitory molecule mostly, so it does have an emotionally blunting effect. So if you had nothing else being regulated except the amount of serotonin, then it does kind of make sense. What makes you pee pee poo poo? Usually like pizza. If I eat a lot of cheese, you know, I got my cheese crisis. Actually, I think there are parts of the brain that are activated, like in the monoamine system, that are activated when your bladder is full. Because again, these are all about communication. These are all about like things you don't even think about on any sort of level. So you know, maybe some of these could make you pee pee poo poo. Zoloft is another one. Zoloft is a classic sertraline. This guy has really high affinity for the dopamine transporter. I mean, sorry, for the serotonin transporter. The highest actually out of these two. And then it's got a little something. A little something for the dopamine transporter. And then lastly, I just want to, this is foreshadowing, okay? This is just a little foreshadowing. That's why people have the pee-pee my own pants. Prescribe antidepressants to end the pee-pee in my own pants fetish. Oh my god. Yeah, I don't know. I mean, I wonder if there's constant activation of that area. Paroxetine or Paxil, I wanted to show because I'm gonna bring it up when we talk about dick and balls, but it has a really high affinity for CERT, more than these guys. And then also, it's got some affinity for NET, which is really, really weird, really interesting. You don't really see that with SSRIs. There's another class of drug that deals with serotonin and dopamine, or serotonin and norepinephrine, and not usually SSRIs. So, I wonder if this is gonna come back ever. So, I mean, these are only slight differences that we're seeing, but they do account for the differences in side effects that we see, with SSRIs, different SSRIs, and for you know, some of them are better at treating certain things. They're all antidepressants, but Like, for example, Zoloft I've heard is pretty decent at treating like OCD symptoms, whereas the other SSRIs probably are not really like that. But yeah, these little tiny differences can have that sort of effect. And of course, there are two main downsides to SSRIs that causes people to sort of prematurely quit them a lot of times, and that is they take forever to kick in, and they cause sexual dysfunction. That is famously.
Also happens.
Yes, famously they cause these things. So let's take a look at them. So by far, sexual dysfunction as well as weight gain, but those two are the most common side effects of SSRIs. And this table here shows the percentage of people in a study who experienced sexual dysfunction based on which SSRI they were taking. So at the top here, citalopram. Abilify? No. But that Abilify is something. Abilify is aproprizole or something. Okay, you look up citalopram because escitalopram is Lexapro. Celexa? Is it Celexa? Yes. Okay.
I was not on.
Yeah. No, you were not. So Celexa, citalopram had the highest incidence of sexual dysfunction, followed by Paxil or paroxetine. Oh, you were? How was that? I mean, my assumption is that it didn't work out too well if you were only on it for a short amount of time. I think this one tends to have a lot of side effects. Extreme head pain. Oh man. Oh. Yeah, I wonder if it causes like some sort of like constriction in the blood vessels in your head. Why did they take a minute to take effect? Aha! That is after sexual dysfunction. I'm gonna get right into that. But first we gotta talk about sex, baby. We gotta talk about you and me. So Celexa, very high, 72% in this group of people. And I highlighted the SSRIs. So these other classes aren't as associated with why the Kumis can't Kumis. They're not as associated with sexual dysfunction. And there are different studies have different numbers, but something that I did notice in all of them was that one, SSRIs do cause a lot of sexual dysfunction, and two, paroxetine is always on there, is always one of the highest one. Fucking Paxil. So sexual dysfunction, there's a lot of different aspects to that. It's not just one overarching thing. So you can have decreased libido, which is just that's motivation. It's your motivation to engage in sexual activity. You can have delayed orgasm or just fucking no orgasm. And you can have erectile dysfunction or impaired lubrication. People don't necessarily have all of these at once. In fact, you can certainly have a really high libido and not be able to come. Like there's different things going on there. And if we'll look at these numbers here, we have Prozac, Paxil, Luvox, Zoloft, and Celexa in these studies. Yeah, Blue-Vol, exactly. And then we have the incidence of these individual aspects of sexual dysfunction. So, something that I definitely noticed is that decreased libido tends to be the most reported one. Only in these two guys right here is it not the most common side effect. Yeah, 100%. Yeah, these things really, as we're seeing here, they really affect libido. I mean, I think a headache is I don't know how common it is, but it is a side effect of SSRIs. And And I would imagine that could be from serotonin actually was named, the word serotonin comes from what it does in the blood, which is constrict. So I think that medication clearly changed your neurochemicals in some way such that the serotonin may have been causing increased literal blood pressure in your brain, I would say. It's Sarah's the tonin, exactly. Sarah's the tonin. Your brain got Sarah'd right in the tonin. But yeah, that's my best guess is you had increased blood pressure, and the reason why that SSRI might have done it and possibly not other ones is just there was no compensatory thing to make up for the increased serotonin. That's why SSRIs are like, really hit or miss sometimes. They only affect one thing, and it's not just one thing that makes us depressed. Well, you still got serotonin. Everyone gets serotonin, whether it's their headache or their genital and mind genitals don't work. Mind genitals. But yes, libido is number one, the thing that it kills. And obviously, like, having trouble having an orgasm and then not having an orgasm at all. These are clearly, like, different mechanisms going on because the SSRIs seem to preferentially affect one of those things over the other. And the last thing that I think is the most interesting is when it comes to erectile dysfunction or vaginal lubrication, these numbers are fairly similar with, Celexa is a little raised. Paroxetine is like 2 times the incidence of erectile dysfunction in this group. So I think that's interesting. I think it's interesting. And we're gonna see. 'Cause, I mean, this is not fair, right? Because depressed people have enough going on, and they probably already, without the SSRIs, have a decreased libido or some sort of sexual dysfunction. And then we go ahead and we take the fun out of sex. Or are we putting the fun in with dysfunction? No, it's okay. Anorgasmia sounds like a Final Fantasy name. Oh my god. She's a mage, never heals you. Never ever heals you. Heals herself, maybe heals other party members, does not heal you though. Okay, so why is this? What the hell? Why the hell is this happening to people? We're gonna look at these categories individually because these two especially, these are very similar. They're more physiological. Because like I said, you can have a really high libido and still have trouble orgasming or even have trouble getting an erection. And that's because they're just so different. I mean, you can possess the motivational and appetitive aspects of sex without while having problems with the physiological aspect. It's a real double-edged sword. It's a real double-edged dick. A real double dong dildo over here. But the culprit is serotonin. Okay? It's fucking serotonin. Fucking serotonin. It's the cause. Because the thing is, libido is your sex drive. It's your motivation to engage in sex. What neurotransmitter do we think about when we think about motivation? It's dopamine. That's dopamine's thing. It's not serotonin's thing, it's dopamine's thing. And serotonin actively inhibits the dopamine system. But we want that, okay? We want serotonin to do that. Because here's the thing. Low serotonin is associated with aggressive and impulsive behaviors, which again are dopamine things. So if you don't have enough serotonin to, you know, be the big sister and prevent the impulsivity and the aggression, then, you know, that's a problem. So in normal levels, we do like serotonin. We want it to regulate those systems. But because SSRIs really increase the amount of serotonin, the effect is that our libidos are lowered, and a lot of other stuff apparently. Oh, hunger suppression as well. Because like I said before, as you eat, serotonin goes up as a way to eventually decrease appetite. Um, so, yeah, libido is I think that's another thing people don't understand is libido is a type of motivation. And serotonin's whole job is to inhibit that. Delayed orgasm or anorgasmia is like a lot more complicated and kind of confusing, so I'll try to explain it as best as I can, but what made the most sense to me was to think about like serotonin signaling in pain, like we looked at earlier, where we had the ascending and descending pathways. Um and how the TCAs were able to increase norepinephrine in order to stop uh, pain signaling and pain perception. I feel like it's a little similar here. Like, what makes it also more complicated is there are more, obviously, there's more things going on that can make someone have trouble orgasming, like their mood or, like, I don't know, um, like anything, even your libido. Your libido can affect that, but we do know that the spinal cord relays pain information, and guess what? It relays other information too. So that would be maybe information from your downstairs areas, probably. That is a testicles with a emphasis on the vas deferens.
Like how it has big like.
Your vas deferens is hitting is smoke, is token mad smokes or whatever. Oh my god.
Right.
Okay, so I guess the best way to look at it is like we have the sympathetic and parasympathetic nervous systems. And in general, as we're going to see with like erectile dysfunction, the parasympathetic nervous system activates certain things about sexual function, whereas the sympathetic has the opposite effect. It inhibits. So it's possible that increased serotonin is blocking sympathetic input to the muscles involved in orgasm. And the reason why it's sympathetic input is because that's like the muscle contraction. So orgasm obviously involves different muscle contractions. So the fact that you can have sexual motivation and not be able to orgasm, this does kind of make sense then. If there's something that is physically preventing those muscles from um contracting to their full potential. It's very weird. But lastly, serotonin can lead to erectile dysfunction. And also vaginal lubrication, but we don't know that much about vaginal lubrication because it's female shit and we don't know female stuff. All I know is that there's like some sort of parasympathetic vasoconstriction in the vaginal area that leads to increased interstitial fluid, which leads to vaginal lubrication. Maybe. I don't know how serotonin affects it. Erections, though, those are important. Dicks are important, so we know a lot more about fucking erections. So basically what would happen normally is that parasympathetic nervous system, excuse me, activation of parasympathetic nerves leads to the production of a gas hormone called nitric oxide, or NO. And nitric oxide causes vasodilation. It opens the blood vessels in the penis, allowing blood to flow in, and then you have boner. Serotonin inhibits that. Serotonin prevents, it's involved in vasoconstriction, so it prevents the creation of nitric oxide, which prevents arterial dilation, which prevents a boner. I mean, serotonin, the literal cock blocker. So paroxetine. I was being weird about that one earlier. Why would the serotonin blocking make sense? Well, because a lot of these things happen in like a split second, right? So normally if you have like let's say someone with a dick is just having like normal sex and they're totally everything's fine and they achieve orgasm and they ejaculate. It's just like that hunger example where serotonin is involved more in satiation. So after you've like achieved orgasm and your body doesn't like need to have a boner anymore and shouldn't. It's really bad to have a boner for like a really long time. Then that's where you get this increase in serotonin to come in and constrict the blood vessels and make the boner disappear. Norepinephrine is also involved, as we're going to see, but evolutionarily this makes a lot of sense because a lot of survival is dependent on energy consumption and energy organization. No, there's a better word. Yeah, energy balance, like figuring out where in your body you're wanting to expend the most energy. And it doesn't make sense to it doesn't make sense to expend a lot of energy doing that. I think, and what always gets me with some of these things is I see some of these systems and how they affect each other, and I'm just like, how is this possible? And then I have to be like, oh yeah, it's like a millisecond. It's barely a thing that happens, and then it goes back up and down and up and down. It's these aren't like permanent changes, and it's so funny. But speaking of norepinephrine, I mentioned earlier, paroxetine, Paxil, and how it seemed to really, really cause erectile dysfunction more than the other SSRIs. That was also the SSRI that had some activity at the norepinephrine transporter. It was the only one actually that had that. Oh yeah, that makes sense. It's really it's so easy to confuse them also just because they're always talked about in conjunction with each other. Uh, and as a molecular biologist, I believe that talking about disease is always the best way to understand things. So I think what really divorced them in my mind was studying schizophrenia, where too much or too little dopamine or too much or too little serotonin do just completely weird fucked up things. Uh, so and I think and even with, like, erectile dysfunction, it's so much easier for me to understand what is happening with erectile dysfunction than it is with, like, just an erection. Diseases are, like, just so helpful. Um, but yes, Paxil. Uh We saw also with pain, norepinephrine activating the sympathetic nervous system. When we activate the sympathetic nervous system, that tends to lead to local vasoconstriction, which is anti-boner. If you constrict, you can't get the blood to the place where you want the blood to go. So, this is just my personal thought. I don't have any confirmation on this, but my thought as to why paroxetine causes so much more erectile dysfunction is its action on preventing norepinephrine reuptake. And if you have more in your body, then you just have more sympathetic activation. And so that makes it harder to get an erection. But yeah. Do SSRIs make a little more sense now? I know I talked about like literally 50,000 things in 5 seconds, but I am hoping that SSRIs make sense. If anything, I probably made it make less sense because I feel like the typical explanation for SSRIs is you get more dopamine, and I just said so much more than that. The confusion of serotonin. Oh, okay. Hell yeah, that makes sense. Yeah. Fuck yeah. Get fucked. And it's so just like, well, I guess you know what we're gonna see in a sec because there's that other thing that sucks about SSRIs, which is therapeutic lag. But first, I just want to point out this interesting thing that I found. It was studies about what side effects of SSRIs cause people to stop. And reduced sexual function and weight gain were not associated very much with treatment discontinuation. It was other things like mood effect, anxiety and agitation, suicidal thoughts, of course, and then like vomiting and rashes. So more physical effects were making people, want to stop, but oddly enough, not so much the sexual dysfunction. That was interesting. Therapeutic lag. It's just God. Jesus Christ. It's very complicated, and even the leading theory out there is not completely right, but I'm gonna set this shit straight. They could be lying, but there's two things. So some of these studies measured incidents of people spontaneously reporting sexual dysfunction and people who reported it when they were asked. And when they were asked, people like a way higher percentage of people reported it, but yeah, people tend to, it depends on how the study is because if they don't ask about it and then they just go off of what people report spontaneously, people are not going to volunteer that they like that sex is bad now. Like these just are not, it's not things that people are going to just volunteer. But like we could say that with any study. And anytime, anywhere, anyone could be lying. But I will say with that study, they didn't go off of spontaneity. They like asked people like, "Hey, I'm trying to figure out the side effects. Do you have sexual dysfunction?" So, I think the weight gain was also just like a really interesting thing because those are literally the two most common side effects. And they seem to have such less bearing on people quitting. Okay. So therapeutic lag. It's really cool and awful, but it's not a lag in the time it takes serotonin to be increased. That happens that happens so fast that serotonin reuptake inhibition, it's really fast. It's the effects. It's actually feeling the antidepressant effects that take a really long time. And that during that time people might even feel worse than they did before, which is very dangerous. And the main culprit is well, okay. One of the main culprit basically has to do with the 5-HT1A receptor, which wears two hats. It is an autoreceptor and a heteroreceptor. So, it is mostly the autoreceptor that is blamed for this therapeutic lag. And here's why. Its main function is to actually inhibit serotonin release. It's negative feedback, which again, we like this stuff. Normally, in normal brain, we like feedback inhibition. We want everything to be nice and regulated. So it hangs out on presynaptic neurons. So this is the neuron that releases serotonin. It hangs out on its own neuron And when there's serotonin in the synaptic cleft and it binds this receptor, the effect is that less serotonin gets released and that neuron decreases its firing rate. And which is, that's like the definition of negative feedback right there. So when SSRIs initially increase serotonin by blocking the transporter, a lot of these receptors start getting activated. And, like I said, it's normal. Your body doesn't know, oh, there's Prozac in me and it's doing this. Your body doesn't know those things. All your body knows is, oh, there's increased serotonin. I'm going to do my thing and do negative feedback. So, that's what starts happening with the pretty significant increase in serotonin with SSRIs. You get so much receptor activation that a lot of these serotonin neurons really decrease their firing rate, and sometimes the receptor will also internalize itself. So you are also getting a decrease in the density of these receptors on the neurons. If your bussy isn't regulated, I'm calling the police right now. You cannot be walking around with an unregulated bussy. You heard it here, folks. Amy's bussy is not FDA approved. I would love to do Ozempic. Ozempic is really cool. I would totally do that. Mayhaps the next one. Drug discussions about drugs really tickle my molecular thing. My little molecular G-spot. Adonis is obsessed with Ozempic. Adonis needs to he's like Tourette's. He has to say Ozempic at least every 90 seconds. He has to. It really does. It has to be in every other sentence or he will die. It's required. I might do this for Ozempic. I should have Adonis on as a guest, and he could just say Ozempic on a schedule. Okay, where are we? 5 HT1A autoreceptor. It is with SSRIs we have lots more serotonin, so they are being activated to decrease serotonin release and firing. They are being internalized so that receptor density is less. And so the overall effect starts to be a actual decrease in serotonin release and firing, because the amount of serotonin that the SSRIs prevented from being taken up, that starts to be insufficient, right? Because you don't have, the idea is you are supposed to still constantly be releasing serotonin at a regular rate. So it starts to be insufficient. These are all, this entire time I've been talking about autoreceptors. Serotonin heteroreceptors are just serotonin receptors on non-serotonin neurons. So they're elsewhere in the brain. Most of the serotonin is made in the Rafe nuclei. So heteroreceptors are not going to be there. They're going to be elsewhere. They're going to be activated by serotonin elsewhere in the brain. And those guys don't seem to really be affected by this therapeutic lag mechanism as much as the autoreceptors. Over time though, the idea is that the autoreceptors desensitize to serotonin. And they start responding less to serotonin. And as a result, the sort of feedback inhibition is getting lifted, and you can now make your own serotonin again, and you can feel the mood elevating effects of the antidepressant. That's not the whole story though. I don't think it is. Cuz look at these connections. There's so many so many circuits and wires in your brain that it just cannot be this simple. Like, there's ideas out there that I think I agree with, that the desensitizing of the receptor and the lifting of the negative feedback are not, they're coincidental. They don't cause each other. So we talked about the receptors desensitizing to the serotonin. They don't respond as much, and so then the neurons can fucking make their own serotonin again. The other thing that happens that we think is separate is the lifting of the negative feedback, the disinhibition of it. So that the changes that are being brought on by the SSRIs lead to compensatory mechanisms that lead to serotonin release. So your brain is being like smart, and it's like, wait a minute, this is weird. I did my negative feedback, but now there's nothing. That's not right. When I do my negative feedback, I should see like a lowering and then an increase and then there's supposed to be a sort of like a rhythm to it. So it's possible that in addition to the desensitization during this therapeutic lag, your brain is also fucking rewiring itself and being like, fuck you, I'm gonna disinhibit the negative feedback. I'm gonna fucking take the back way around, all right? And the reason we think that happened, it has to do with, I didn't write it down, but there was this one study where they used an antagonist on the receptor, and they noticed that the receptors were still like somewhat sensitized, but there was still disinhibition. So the study showed that there is this, you know, it's not just the desensitization. That's not the only thing that's going on. And it's a shame because I think that people with severe depression who Prozac is probably the first thing everyone goes on. That's the first one. And if it's not Prozac, it's another SSRI. SSRIs are like always the first thing. Zoloft, yeah. Boom. And if you are feeling horrible and then you have to go through this therapeutic lag, it's just dangerous. It sucks. It's commendable that people get through this, and I think that people certainly do get through this and then they feel great and they feel fine, but you know, the fact that, foreshadowing, the fact that we're only really affecting the reuptake of serotonin and we're not doing all that much on the receptors, or any other receptor indicates that there's probably more that can be done. Now, I have to talk about suicide for a second. And I'm gonna put a gif of Linda Belcher dancing. So as long as if you don't want to hear any of this, I'm not gonna spend a lot of time here. But if you don't want to hear any of this, you don't. When Linda is off the screen, you are safe from serious suicide discussion. It might still come up, but this is like what it's gonna all be about. So you'll be safer when Linda is off the screen. And like I said, I don't want to spend a lot of time here. Anyway. So suicidal behavior and ideation is not a common side effect of SSRIs, but it's associated with it still to an extent. And there's a lot of conflicting attitudes and results when studying whether or not SSRIs actually increase suicidal behavior. And it is particularly hard to study in completed suicide cases because people with psychiatric conditions are already predisposed to suicide and suicidal behavior. And a criticism that often comes up with this is the fact that suicide and suicidality are distinct ideas. Um, it's because suicidality it includes suicidal behavior and ideation. Um, and it's difficult to measure and conceptualize because the reality could be that while SSRIs might increase suicidal behaviors, they might increase suicidality, they actually still prevent people from completing suicide. And I know that that sounds like it doesn't make much sense because, you know, increasing the behaviors is like increasing the chances, but statistically that might not be the case. So, it's hard to study for these reasons. Um, and for the most part, there really isn't that much of a connection between SSRIs and, suicide. The the most significant finding is that age plays a role. Um, Children and adolescents under 25, um, they are twice as likely to develop suicidal behaviors, during SSRI treatment, and that fact is what caused the FDA to put a, box warning on, SSRI, um, in 2004. In reality, though, so let's see, Prozac was the first SSRI, came out in 1988. In reality, the years, like, kind of immediately preceding the onset of SSRIs being prescribed, there was a decrease in, um, completed suicides. And I'm gonna be honest, I really couldn't find quality data about why that was because it's just statistics. That could be because of anything. I mean, what happened in 1988 to 1993? Like, more things happened than just SSRIs came out, is what I'm trying to say. So I don't know about the quality of the data, but there are still a lot of things that can predispose people to this kind of behavior, and they should still be concerned about these things if they want to start SSRIs. So that's going to be when you start treatment, that tends to there's a lot of changes going on in your brain, and that can increase suicidal behavior. Same with dose adjustments and discontinuation, especially discontinuation. If you just stop taking a medication, that significantly increases your chances of these types of symptoms. Having major depressive disorder disposes you, as does a history of suicidal behavior. These things are unsurprising. Um, but this is something that brings SSRIs under fire, is the suicidal behavior thing, and it's really not as prominent as people think, and it's really just in children and adolescents. And interestingly enough, Prozac is one of the only meds, yeah, really one of the only antidepressants approved for younger people. Um, and I'm not entirely sure why that is, especially if there's all this stuff about how it increases, suicidal ideation. There's clearly something about it that makes it a little safer for kids than other meds, but you know, it it's just interesting. Uh, and of course I wanted to bring it up because this it really is like the worst possible side effect and like the worst feeling that you can ever feel in the world. And if you finally decide like I want to get this under control, and they're gonna put you on an SSRI first, they just are, that's how it works, then, I think that people should have more realistic information on what these types of side effects are and how it's gonna affect them. Uh, and what was the last thing? Um oh, yeah, there's a lot of the studies are, like, people who are already suicidally disposed before their treatment, and then it continued during treatment. That doesn't really tell us anything. And that's a lot of the studies where these are the numbers that they're giving me, and it's like, if someone felt like that before treatment and then they kept feeling like that, that probably means that the medication is not working for them. it doesn't mean that the medication is making them like that. Like, that makes no sense. So a lot of these, there's just such low quality information out there about this. Okay. We're done. We're done focusing on suicide. Again, it might come up. It could still come up later because, mental health, but I'm done for now. Linda's going away. Okay. So, despite all this, despite what I just said about, that stuff, SSRIs, they're the first psychiatric drug that people tend to try, not just because they're well known and technically safe, but because, again, Prozac is one of the few that's approved in young people, and a lot of people started experiencing depression during the teenage years. This is the chart, by the way, that I've used to pick my examples that I've wanted to use. And you're going to see some of these come up as, of course, examples for the remaining antidepressant drug classes. As you can see, in America, we like SSRIs a lot. That's our favorite. And that's why I went into a lot more detail for them than I will for the rest of them. But in the UK, they tend to prefer some other classes besides just SSRIs. But of course, I went off of America because I'm America. The next drug that we're gonna look at contains the medication Wellbutrin, which is very popular. As you can see by its number 3 spot on this list. Wellbutrin is not an SNRI though. I don't know why they put that. It's wrong. It's not an SNRI. It makes me trust this information less, but here we are. Wellbutrin is not an SNRI. It is an NDRI. Jesus. A norepinephrine dopamine reuptake inhibitor. That's right. We're ditching serotonin for now. Fuck serotonin. I'm just kidding. Baby. Come back. Friendship ended. It has the same basic goals as the other classes we talked about. Mood elevation to treat depression. Only we're changing the neurotransmitters that we care about the most. Because dopamine can turn into norepinephrine, by the way. I want to just say that. See, right here? This is dopamine. And then you take it and you put a little on it. And then it's norepinephrine. Anyway. Much like SSRIs inhibit the serotonin transporter SERT, these drugs inhibit the transporters for these two guys. So it inhibits NET for norepinephrine and DAT for dopamine. They are this class is just as effective at treating depression as the other classes we looked at, excluding MAOIs. We don't care about those. But there are definitely some notable differences, and there are some reasons why someone might take an NDRI instead of an SSRI or in addition to an SSRI. So just because they don't affect serotonin very much doesn't mean that we're, blowing the monoamine hypothesis completely out of the water. But it definitely makes us think about some stuff. Fun fact, there are some stimulants that have NDRI activity, like the illustrious Ritalin. It affects the reuptake of both of these neurotransmitters, but it is not an antidepressant because it is a stimulant that is mostly used for ADHD, not depression. And ADHD probably is associated more with deficits in these two specific neurotransmitters. So, since NDRIs can have a sort of stimulating effect, they can be used to treat narcolepsy, and therefore are also good for people who have like hypersomnia associated with their depression, like they're sleeping too much. This can help get them up. And also it increases dopaminergic neurotransmission. So I didn't know this actually. I thought this was interesting. NDRIs are used to help with Parkinson's as well, which if you don't know, Parkinson's is the destruction of dopaminergic neurons in the substantia nigra. And so it obviously, I mean, I didn't look up the exact mechanism. This is just based on what I know about these things separately. But if the NDRIs are able to spare some dopamine by inhibiting the reuptake and thus helping with Parkinson's symptoms. So I thought that was cool. I didn't know that. Okay, so Wellbutrin, bupropion, is the most well-known and most prescribed NDRI. It is not just for treating depression, but also it helps people quit smoking cigarettes. It works a bit differently than other antidepressants. It's not like other girls, which is why it is considered an atypical antidepressant. It is not associated with the two most common side effects of SSRIs, sexual dysfunction and weight gain, which is pretty huge. That's why some people, if they don't take this instead of an SSRI, they'll take it in addition to, and it can sort of counteract those unsavory side effects of the SSRIs. And like I said before, it improves hypersomnia, and because it has a slightly stimulating effect, it also improves fatigue. You know, some big depression-coded things. It's not magical. It's not like magic though, because in some people it can cause insomnia. I mean, if it's too stimulating. And SSRIs alone, instead of NDRIs or instead of the addition of an NDRI are more effective for treating depression that has anxiety because the activating effects of Wellbutrin can be depending. There's lots of types of anxiety, and depending on the type, it can be more detrimental for those people. Looking at the pharmacology information, it has a sweet, sweet, sweet affinity for these two guys with a slight preference for the dopamine transporter. And obviously increasing the neurotransmission of norepinephrine and dopamine is what underlies Wellbutrin's antidepressant effects. These two specific neurotransmitters really help with some of the landmark depression symptoms like not just the hypersomnia, but also certain deficits in like motivation and attention. So yeah, it helps with very dopamine coded things like attention and motivation. And anhedonia, which that's the, the lack of pleasure basically. One of the shittiest symptoms, and so having this increase in dopamine neurotransmission can be very effective at alleviating that. And so, serotonin is still important. And the fact that DAT and NET can likely still affect serotonin in a positive way, really, I mean, this is how NDRIs demonstrate the importance of other monoamines in the treatment of depression. And I gotta mention these guys down here. So these are nicotinic acetylcholine receptors. And Wellbutrin clearly has some affinity for them. And that makes it a decent helper for helping people quit smoking. Like it decreases withdrawal symptoms and it can help decrease cravings as well. And it prevents the weight gain associated with nicotine withdrawal. All by antagonizing those receptors. All right. Finally, I don't know. More reuptake inhibitors. This time it's serotonin and norepinephrine. We are in the 90s, and this is where we invent SNRIs, and the first one being venlafaxine or Effexor, which was approved in 1993. It was the first SNRI, and it was the first drug approved for diabetic neuropathy. As the name implies, it blocks the reuptake of serotonin and norepinephrine. And it's TCAs kind of have a similar mechanism as we saw before. But the SNRIs tend to be more tolerable because TCAs interact with more things and therefore cause some more side effects versus the SNRIs. Because remember, the TCAs combine serotonin receptors and histamine and adrenergic and muscarinic receptors, which causes therapeutic effects but also side effects. SNRIs also have some anti-inflammatory properties, which, I mean, I don't want to, again, not trying to shit on the monoamine hypothesis. Don't want no one to shoot me from big monoamine hypothesis, but inflammation is seriously implicated in depression. And so the fact that this has anti-inflammatory properties potentially makes it pretty effective. Hold on. I now I want to make it that. I'm doing it. Oh my god, that's so funny. So these bukkake inhibitors are anti-inflammatory, which is awesome. Because that is another sort of hypothesis surrounding depression, is that there is increased inflammatory mediators. This table is comparing the ratios of different SNRIs inhibition of the serotonin versus the norepinephrine transporter. Of course, Prozac is an SSRI, so it really doesn't care about the norepinephrine transporter. It exclusively inhibits serotonin. So funny. The TCAs differ a lot in their selectivity. Like amitriptyline has still obviously more of an affinity for serotonin, the serotonin transporter, but it's not exclusive. And then the SNRIs are even less. Duloxetine is going to be our example for the SNRIs. If we look at just the SNRIs, the first SNRI, which again is venlafaxine or Effexor, has the highest selectivity for SERT out of these guys. And then duloxetine, again, has a much lower ratio, but also a much higher affinity for both of the transporters versus Effexor. Duloxetine is the most prescribed SNRI in the US, so that's going to be my star child for now. It came on the market in 2004, and even though its exact mechanism isn't known, we can get the gist of it. It has a pretty high affinity for the serotonin transporter, more than Prozac it looks like. And then there's no interaction pretty much with other receptors, not even DAT. We don't even care about the dopamine transporter. It is just serotonin and norepinephrine and no other receptor. However, duloxetine can still increase dopamine in specific areas of the brain. So we're gonna revisit really quick the monoamines and what their role is in relation to depression. So serotonin mediates cognition, mood, and anxiety. Dopamine helps with some of those things and works in motivation, reward, and attention. Norepinephrine also helps with some of those previous things and is involved in alertness and energy. They overlap even more than, like, so much more than this. Yeah, they overlap a crazy amount, which is why the monoamine hypothesis sort of it starts shifting from we need to increase these things to we need to regulate these things. Maybe more is only better if we consider which parts of the brain we're dealing with. And duloxetine gives us a taste of this tailored response. Because here's a little secret. The norepinephrine transporter is cool with dopamine. It's like, hey man, you're just like norepinephrine, but you have without that little hat on you, without that hydroxyl group, you can come in. It's totally fine with letting dopamine pass back into the neuron. And another secret is that there aren't that many dopamine transporters in the prefrontal cortex. Yes, the prefrontal cortex, the PFC. You know, the part of your brain that helps you with planning and, goals and talking and attention and all those really important things. Oh, making decisions and recalling information too. There's not much DAT in that area, but since there are populations of NET in that area, duloxetine can still increase dopamine neurotransmission, specifically in the prefrontal cortex. Which is good because this circuitry obviously tends to be dysregulated, and PFC volume actually tends to be smaller in depressed patients. I won't go I won't torture you. I won't go into too much anatomy, but this part of the dopamine pathway right here, this is the mesocortical pathway. In the absolute simplest terms, dopamine, through the reward system, communicates with the PFC to help with, you know, yes, to help inform decisions and set goals, which, obviously low dopaminergic communication with the PFC, and also between the PFC and other structures, this can contribute to feelings of low motivation and anhedonia. Classic low dopamine thing. Granted, it's much more than just low dopamine, I'm aware. And there are actually a lot of subdivisions within the PFC. It's not just like it's the PFC. There's a ton of different structures within it that are implicated in this. But it is more accurate to say dysregulated, dopaminergic neurotransmission. But in the case of duloxetine, the fact that it increases NET, and that increases dopamine in the PFC, that is what sort of underlies its help with those symptoms. The other antidepressants we looked at don't really have this tailored response. And the newer ones that we're going to see, you'll notice more attention being paid to attenuating side effects and having more specialized pharmacological profiles. Cymbalta good for ADHD? Maybe. A lot of the these medications help with a lot of things, and I didn't, like, list every single one of them, but it's possible that this totally gets, prescribed for, ADHD, especially, like, if the ADHD is associated heavily with depression. I think a lot of these are kind of dual purpose, they're good for those things. Although, ADHD isn't always associated with low dopamine in the PFC. Am I thinking of ADHD? I only studied depression, so I would love to look more at ADHD though, because, like depression, ADHD, schizophrenia, they all have problems with dopamine, but they're somehow so different in terms of where the deficiencies or the, what's the word for too much? Or the excess, where the deficiencies and the excess are. But in a lot of senses, they affect the same. Like, even just looking at these words right now, it's like very ADHD coded. Um, yes. This, which one did I compare to Ritalin? It was the NDRI. Yeah, NDRIs as well and SNRIs have this right here, this, fucking, it's called a substituted amphetamine. And a lot of the NDRIs and SSRIs sort of not always have this structure, but they have that sort of effect. And it's definitely, like the lack of caring about serotonin, I think that makes it good for, ADHD. 'Cause really it's dopamine and norepinephrine that are completely fucked with ADHD. But yeah, that's cool. I think I wait, oh, now I wanna look at my Aw, I thought, atomoxetine would be on here. Losers. But yeah, that was another thing that I also struggled with was, when I'm talking about mechanisms, it's like, oh, there are TCAs that are not antidepressants, and there are SNRIs that are not antidepressants. And I wanted to talk about everything, but, I was like, "No, just depression." Okay. At some point, we wanted an antidepressant that was less toxic than, TCAs and that selectively binds, the serotonin receptors that we wanted them to bind. You didn't steer me off course. I love this. If I I like the extra information. I don't feel steered. Plus, you know I always give back. I bring myself back. I'm not my sister. You don't need a frickin' backpacking backpack and 4,000 feet of rope and a supply of food for 5 weeks to bring her back to the point she was trying to make. I love her. It's good. I'll backpack anytime to her. Uh, but finally we wanted serotonin reuptake inhibition, but maybe instead of all that, we could just bind the receptors. What if we just went straight to the source? And so Mirtazapine, aka Remeron, was approved in 1996. And look at this guy. This guy has 4 circles. 4 circles! Another circle to the molecule. This is a tetracyclic antidepressant. And this new chemistry makes it a stronger antihistamine, so it will still have sedating effects. It doesn't block the reuptake of norepinephrine or serotonin at all. Much like amitriptyline did. And then they also have a higher affinity for the alpha adrenoreceptors. Which they antagonize, they block them. And then, unlike TCAs, which will bind muscarinic cholinergic receptors, tetracyclic antidepressants don't have much affinity for the cholinergic receptors. Mirtazapine, in addition to being a tetracyclic antidepressant, mirtazapine is also classified as a noradrenergic and specific serotonergic antidepressant, or NaSSA. I don't know what my problem is. I just think this is dumb. I just don't like it. I just don't like the name. So we don't care about reuptake inhibition. Mirtazapine goes straight to the source. It antagonizes these serotonin receptors. 5-HT2A, which when we antagonize it, it decreases anxiety and increases sleep. In 5-HT2C, we see a decrease in sexual dysfunction and an increase in appetite. And in 5-HT3, a decrease in nausea and vomiting. 5-HT3 antagonists are actually a whole other class of drugs on their own. They are antiemetics. And blocking them is anti-nausea. So, the weight gain thing. So remember that serotonin is increased while you are eating, and then it decreases appetite. That's kind of the main unsavory side effect of something like mirtazapine, where we have antagonized all the receptors that we want, and we have all of these good effects, but antagonizing the 5-HT2C receptor prevents serotonin from binding and decreasing appetite. So when we antagonize it, the effect is an increase in appetite. And therefore, potentially weight gain. So this is at lower doses of this drug. At higher doses, we see binding to the adrenergic receptors. Both the auto and hetero receptors. Remember that auto receptors are on their own neuron. An adrenergic autoreceptor is on an adrenergic neuron. And when that happens, and we antagonize them, normally, again, it's that negative feedback thing. If we're blocking them, we're preventing the negative feedback and therefore increasing the release of norepinephrine from these cells. And it also, to a lesser extent, will bind adrenergic heteroreceptors on serotonin cells, which leads to a small increase in serotonin. It's not like a crazy increase. And with these specific serotonin receptors being blocked, and with this sort of modest increase in serotonin neurotransmission, this frees up a completely different receptor to be agonized by serotonin itself, which is the 5-HT1A receptor. Binding this receptor in the prefrontal cortex increases dopamine neurotransmission there. Similar to the effect that Cymbalta has, only through a completely different mechanism. It doesn't involve the transporters at all. Um, so this is an interesting mechanism. It's different from a lot of the other ones that we've looked at because it has jack all shit to do with the transporters. I mean, the other ones were all about the transporters. This one is all about the receptors, and it is, as we've seen before, kind of agonizing certain serotonin receptors has effects that we don't want. But this one, it's a specific serotonergic antidepressant, so it's specifically designed to bind um, receptors that are gonna have antidepressant effects and not increased anxiety or increased sexual dysfunction or anything like that. Um, and I also think it's interesting because it I think it's really cool that it's freeing up the serotonin that we make on our own to bind a completely different receptor. So even though it's not actively, blocking that receptor, it is still a tailored response. It's still like, hey, we're not binding this one at all. So, hey, any of the serotonin that you're making yourself, it can just bind this one and not all the other ones that we blocked. I think that's just really interesting to me. Um, so we know, we know that there's more to serotonin. There's more to depression than just serotonin, but it's still just a really significant part of the disease. And that's why a lot of newer antidepressants are serotonin modulators and stimulators. They not only prevent serotonin reuptake, but they also show activity and efficacies at a number of serotonin receptors. Um, so wait, yeah, this is vortioxetine. Is pretty new. I think it was approved in 2013. Yeah, 2013. The brand name is Trintellix, and I just feel like the new brand names for antidepressants, it's like when people name their kids Braden or something. Yeah, exactly. The EIGH and Braden. Twinkatrix! It should be named that. Missed opportunity. Oh my god. Yeah, these are just. So these are very different from SSRIs, I think, because we have, you know, our activity at the transporters, but we also have activity at um some of the receptors, which is, remember, not what SSRIs do at all. They don't they promote but don't like participate in serotonin neurotransmission. Um and it's kind of like the best of both worlds here because we want to keep the neurotransmission active, but we also want to increase the activity by directly binding the receptors. Um and Yeah, the design here, the design of this pharmacological profile is very interesting to me. Um, I haven't talked very much about 5-HT7, but it when antagonists bind to it, so when it is blocked, it has like antidepressive and also like cognition promoting effects. Um, so there are people who think that this is just a fancy SSRI, and I definitely have to disagree with that just because like it does SSRIs don't have receptor activity. That's kind of their thing. And this clearly does. And I think that alone is enough for me to be like, yes, this is a distinct entity of drug. Um and I also think that the side effects are probably a lot more improved with this one because much like mirtazapine, we have antagonist activity at these receptors at the 3A receptor and at HT7, but then we have an agonist activity at 5-HT1A. So I think In my mind, the pharmacological profile in terms of the receptors is more similar to mirtazapine. But then mirtazapine has no transporter function. So I think it's like it's the best of both worlds. Prozac was SSRIs really have no affinity. Prozac was the only one that had like the teensiest teeny little affinity for some receptors. So just looking at this number, I think that this is not an SSRI. This is a different thing. This is an SMS. This is an SMS text message. Although people who reported having sexual dysfunction on SSRIs, they went away when they switched to these drugs. So I feel like they're different, you know? And also SSRIs, you know, there's the emotional blunting that we talked about earlier. Some people feel like a zombie if they're on a SSRI for a while. And they felt that less when they switched to an SMS. So I think it's different. Before we go to my final example, I just want a moment of silence for the monoamine hypothesis. It's not wrong or anything. I just want to make way for, like, the realest neurotransmitters. I have talked about GABA and glutamate in every single one of my lectures. They are regulatory neurotransmitters. They're the reason. GABA is the inhibitory neurotransmitter. Glutamate is the excitatory neurotransmitter. Again, no shade to the monoamine hypothesis. I want to make that very clear. I don't want big monoamine hypothesis to come get me, but it doesn't feel right to, you know, keep GABA and glutamate out of this conversation. And I know they don't. Okay, they don't have aromatic rings, so they're not technically monoamines, but they have amino groups. Just saying. It's weird talking about serotonin and dopamine and norepinephrine without referencing the fact that these two queens run all this shit. They do it all. They have connectivity throughout our entire brain. But we're not going to do the whole brain. We're just going to focus on these areas implicated in depression. I'm going to assign the following structures their most associated functions, but just know that they all communicate very heavily with each other, and so they all kind of contribute to these things in one way or another. They all help carry out these functions. So the PFC, we've heard about this guy before. It's involved in emotional processing, especially sadness, and is also involved in attention and motivation. Yes, okay. Hippocampus. Memory formation, not storage. Memory formation. And it specifically encodes memories of emotional context. So it communicates a lot with the amygdala, which also helps encode emotional information. And, you know, there's a reason why a lot of people remember events that had like some sort of emotional significance to them. It has to do with the circuits in this area. The amygdala, we have emotional learning, we have actual memory consolidation and processing, and then we have fear processing. This is just a fun little tidbit. People who have lesions on their amygdala have no fear. They don't have it. They don't process it at all. And then lastly, the insular cortex. This is where your like vision of yourself is, and like your sense of self and who you are is, your emotional perception and your physiological awareness, or interoception, which is your awareness of what's going on inside of you, kind of thing. These are all areas that are implicated in depression in terms of their like anatomy. So a lot of these places, they show decreased volume. in depression, except for the amygdala, which weirdly enough has an increased volume compared to healthy controls. We'll kind of see why in a bit. So the volume differences can kind of point to the creation of maladaptive compensatory mechanisms, aka differential connectivity of inhibitory and excitatory circuits. So let's take a second and we'll just like visualize these structures and we'll visualize them in like a network.
Your little inside brain
Mm-hmm.
that's green.
Yep, everyone has a green inside brain.
That's my little guy.
That's your little guy. Your green inside brain.
And I have the spoon.
They're
Little soft boiled egg.
not spoons. I don't know what they're called, but they're not forks. Amy sucks.
That picture is violent.
I know, I'm sorry.
No, I mean I'm
Okay. We know, yeah. I always just need to say it. Amy sucks. Do you see? Come over here.
but like if
Come
they
over here.
don't- If they don't
Look what she's wearing.
Are these fictional tools? Hi.
No,
I
look
have
at
the
look at the camera. She's just sitting here next to me wearing that.
Mm-hmm. Oh wait. They light up.
Someone save
We
me.
got these at a wedding. At Annie's reception.
Oh yeah.
Yeah.
I forgot. Literal cat girl, I know. It's a price I have to pay, apparently. God made me. All right. So yeah, we're going to visualize these in a network. And we were talking about ADHD earlier. The networks that I'm going to show you are so like messed up in ADHD because they're very involved in like this one working memory and attention and like task switching and stuff like that. But this first one here, brain anatomy is hard and people don't even agree on anything about it, but this is the best that I can give you. These structures get organized into functional networks. So this is the frontoparietal network. It involves communication with the prefrontal cortex and obviously areas of the parietal and it looks like temporal lobe. And it functions in working memory and attention. It has decreased activity in depression. The next is a salience network. Salience is a value prescribed to something, to a stimulus, that makes you want to go toward or away from it. Like makes you want it or not want it kind of thing. So the salience network, which also involves the PFC and communicates between the amygdala and some of the other reward structures, is involved in processing and detecting emotional stimuli. It is decreased in depressive states. And lastly, we have the default mode network, which is the one that's very like heavily implicated in a lot of psychiatric disorders. I wanted to just say that the salience network, it's the opposite for anxiety disorders. The salience network is overactive in anxiety disorders, which makes sense because there is anxiety is about kind of being overstimulated and having like any perceived stimuli is negative. Are negative. But anyway, the DMN, it is active when we're not concentrating on anything. When we're just not focused on anything, that is when this network is the most active and is involved in, processing self, I guess, like thoughts about yourself, introspection, and ruminating. And this is increased in depression. It has increased activity in depression, which is consistent with those classic symptoms of depression of just like incessant negative thoughts, feelings of worthlessness, low self-esteem, and negative emotional biases. So These are the structures. Where do these big D neurotransmitters come in? First of all, monoamines are made in one area of the brain. Right here is where serotonin is made, the Rafe nuclei. Rafine nuclei. And then let's say this is where norepinephrine is made, the locus ceruleus. I don't know how to pronounce it. And then like dopamine is like maybe here and here. It's made in the VTA and the substantia nigra. It's made in one place and then it goes to another place. That's extrinsic modulation. It's from afar. It's made, in this example, we see serotonin being made in the Rafe nuclei, and then it gets released and it goes to all these other circuits. But it's not made anywhere else. Glutamate and GABA have both extrinsic and intrinsic control on circuits throughout the brain. So they are they can travel to other places to have their effect, or they're made on demand, and they exert their effects just intrinsically. They are amazing. So glutamate and GABA are constantly being broken down, remade, recycled, and all this stuff. And you might actually recognize glutamate as one of the 20 standard amino acids. Maybe that makes you realize that we can totally just rearrange its carbons around in super important biosynthetic pathways. No big deal. I love this stuff. Glutamate and GABA make me crazy. Anyway, our brain only accounts for like 2% of our body weight, but it contributes to 20% of our body's overall energy production. Just by sitting there. It just sits there. It doesn't even do anything. And much of this is due to the synthesis and degradation of GABA and glutamate, which are made from glucose, which is our brain's main only source of energy. GABA. This beautiful flowchart, it's so beautiful, shows us the metabolic actions that give us these neurotransmitters, that give us GABA and glutamate. Both of them are made from a completely different amino acid called glutamine. GLN is glutamine. So when GABA and glutamate are just kind of hanging out in the synaptic cleft, kind of these areas in between, hanging out in the synaptic cleft, they eventually get taken up by astrocytes or astroglia, which are just like a support class of neuron. They don't conduct nerve signals, but they are parts of the CNS and they are there to help. In this case, they are involved in the metabolism of these neurotransmitters. When glutamate gets taken up, for example, this is glutamate. It gets a frickin' amino group slapped onto it, and then it gets released by the astrocyte. It goes back into the neuron, where it then gets converted back into glutamate. Easy. Easy recycling. Once it gets back into that neuron, it can then be packaged into vesicles and then re-released and go do its job. It's great. It's a really good system. It's so easy. GABA will also get taken up by astrocytes. And then it does this really weird thing where it just goes into the citric acid cycle, aka the Krebs cycle, and then it becomes glutamate. And then it becomes glutamine again. And then when the glutamine gets taken up by a GABAergic neuron, it gets converted into glutamate, but then into GABA. So glutamate is a precursor to GABA. And when it goes inside of a GABAergic neuron, the presence of this enzyme is what converts it to GABA. Okay. Maybe this seems kind of silly to you. But if you think connecting amino acid metabolism to carbohydrate metabolism is silly, then you just think it's silly to be alive. Okay, here's the thing. I'm mostly telling you this at all because this whole thing is also really, really messed up in depression. First, we talked about how connectivity is messed up, and how the neurotransmission is maladaptive, and how the structural volume is off, and now the metabolism isn't even right. No winning. So, the emerging hypothesis about depression mainly drags glutamate because it's a precursor to GABA. If there's a problem with glutamate, there's a problem with GABA. And I am going to show you the beautiful again. You need this to make this. And you need this to make this. That's just the way it goes. Problem with glutamate, problem with GABA. So the fact that it's a precursor is what makes it really under fire when it comes to depression. So we're going to look at this brain again. And this time we're going to consider what's happening metabolically in these areas. The PFC, the ACC, anterior cingulate cortex. It's just a part of the PFC. And the hippocampus. In depressed patients, there is globally less glutamate to glutamine exchange going on in these specific areas, which leads to a deficit and dysregulation of glutamate activity. With respect to these areas which show decreased glutamate metabolism, here is where we see downregulation versus compensatory mechanisms. Sorry. Downregulation versus compensatory mechanisms of a specific glutamate receptor, the NMDA receptor. Okay. I'll tell you what the fuck we're looking at here. But first I'm going to tell you what this is. This is the locus ceruleus, which is where norepinephrine is made. And yeah. So, in the LC, the amygdala, and the hippocampus, we see increased expression of the NMDA glutamate receptor. As we've seen with the hippocampus, though, there is decreased volume, and yet we are seeing increased sort of glutamate activity here. And the reason for that is because this is compensatory. The lack of glutamate exchange causes an upregulation of this receptor, which is, we've kind of been seeing this sort of relationship earlier of our brain being like, wait, there's not enough of this, so I'm going to do this. Wait, there's too little of this, so I'm going to do this. So with this compensatory mechanism and having it make more of the NMDA receptors to be like, holy crap, there's no glutamate here. Let me increase the chances of glutamate binding these receptors by making more receptors. And this is consistent with findings that the hippocampal neurons in people with MDD are hypersensitive to glutamate. The hippocampus is also very intimately connected with the amygdala. And we also see increases in this glutamate receptor here. And of course, this is consistent with the fact that MDD patients have increased amygdala volumes. The increase in the locus ceruleus was interesting. I don't have much evidence on why that would be. But here's my thought. Stress isn't associated with adrenergic activation, as we've seen. And depression and stress are they kind of commingle a little bit. They have similar mechanisms about them. And so that could be something. I don't know. I also read that increased glutamatergic activation in the LC can decrease behavioral flexibility, which I think is a characteristic of a lot of mental illnesses. I don't know. I don't know much about that. The pic is a meme. After this, I'll have to go back to the MDD circle, and because there's a woman in the middle who looks really funny. So whatever on the LC, there's less NMDA receptors in the prefrontal cortex. And notice that most of these arrows that we see, these red glutamate arrows, they're coming from the prefrontal cortex and not necessarily to it very much. So this means that less receptors there can greatly affect the neurotransmission of whatever areas are connected to the PFC, like whatever areas are being regulated by the PFC. So I mean, that's a lot. A lot of places are connected to the PFC. So the overall observation here is that we have hypofunction of glutamate neurotransmission in the cortical areas and hyperfunction in the subcortical areas like the amygdala and the hippocampus. The differently expressed NMDA in these areas can make this receptor a candidate for antidepressants then. None of the antidepressants that we've discussed so far have any real like direct effect on glutamatergic or GABAergic systems. So are there any drugs that do? In walks ketamine to save the day. Ketamine is derived from our good old friend PCP. Yeah.
How like are
I don't know. I'm not a chemistry.
they?
They're both really dissociative. So ketamine. Pineapple crouton pancake. I'm loving this shit. Ketamine was originally approved by the FDA in the 70s for use as an anesthetic. And it was famously used a lot during the Vietnam War. And it's still used for anesthesia today, also for pain. But it's also used to treat depression. It acts really, really fast because it is both an injection or a nasal spray. So that means the bioavailability is really high. And it reduces anhedonia really, really fast, which is nice. Again, one of the shittier depression symptoms, I would say. Ketamine, it's definitely not a first-line treatment for depression. The IV form is actually not approved by the FDA for depression. It's off-label. Only the nasal spray is FDA approved for depression. But it's appears to be good for treatment-resistant depression. So people who have tried a lot of other things and nothing seems to be working. There is a high degree of a high number of people who try ketamine after trying a lot of other things, and it works well for them apparently. It is dissociative and hallucinogenic, but they don't last super long apparently, and the hallucinogenic effects wear off like before the antidepressant effects start. And then the antidepressant effects can persist for, I want to say, a matter of days or something. Yeah, but for that reason, because it's dissociative and hallucinogenic, you have to go to a place to get the drug, even the nasal spray. O Obviously, with the injection, like, it makes sense to I'm not gonna inject myself with ketamine. You go to a ketamine clinic. But apparently the same is true for the nasal spray. You have to go and have it, like, administered, and then they watch you or something. I don't know. Um, so it sounds annoying. But yeah, luckily those effects don't really last as long, and then you get to experience antidepressant. How does she do it? PCP causes ego death? Oh my god. But yes, how does she do it? She blocks the NMDA receptor. Of course. Look at that. This is also these are the mu opioid receptors, and this is the kappa opioid receptors. So this is where it kind of makes sense that ketamine is used for pain relief because it binds some of these opioid receptors. Um, so with the NMDA receptor though, it blocks it. It blocks the glutamate receptor, but somehow leads to increases in glutamate neurotransmission. How? Well, here's a super fun thing. GABA neurons have NMDA receptors on them. So if we administer ketamine and it blocks an NMDA receptor on a GABA interneuron, that's going to result in disinhibition because GABA is inhibitory. So if you inhibit something that's inhibitory, the overall effect is excitatory. That's what we call disinhibition. So if you have what that ultimately does is you disinhibit downstream glutamate cells so that they can increase their glutamate neurotransmission. It's amazing. What's more is this can actually end up increasing GABA neurotransmission as well, because it disinhibits other inhibitory circuits, I guess. Yeah, it disinhibits inhibitory circuits that are being inhibited. Because we focused on glutamate because, again, it's a precursor to GABA, so it's really, really important. And there's obviously altered glutamatergic activity in certain areas of the brain in depression, but there's also altered GABAergic activity. Um, and I don't understand where those happen as much as the glutamate stuff, but clearly with ketamine increases both sides of this neurotransmission. Um, ketamine ketamine took all of our ideas about monoamines and depression and deep fried it in a delicious glutamatergic roll. Oil. Oil. That sentence was already weird and then I made it weirder. What I'm trying to say is ketamine took all of our ideas about monoamines and rather than just replacing that hypothesis, it added a lot of other factors that we should be paying attention to. Uh Neurotransmitters, receptors, connections, volumes, densities, locations. It's hard to think about all those things at once, to be honest. But maybe at some point, someone will discover the neurochemical key to mood disorders and depression and whatnot. I'm going to set us off not with a revisal of our original hypothesis, but rather an addition. The neurotrophic neuroplastic hypothesis of depression. Neurotrophic refers to nerve growth, and neuroplastic refers to the ability of the connections in our brain to adapt and change. Those with MDD are impaired in these areas, and a part of that may have to do with low levels of a neurotropin called brain-derived neurotrophic factor, or BDNF. This guy promotes nerve growth and survival and differentiation, and it promotes the creation of new synapses, connections. Ketamine has been found to reverse reverse atrophy in certain brain areas in depressed people. And it also improves abnormal glutamate plasticity in the PFC and the hippocampus. So, ketamine's effects on the glutamatergic system, obviously from direct antagonizing of the NMDA receptor, but also we think that it increases BDNF levels, leading to a healthy maintenance of brain connections. Molecularly, it's very complicated, as you can see right here. This is very complicated. These are all normal pathways that are in pretty much every cell, because every cell grows and survives. But these are just BDNF can go through all of these different pathways to promote all of these things in the central nervous system. And it's amazing. Even some of the other antidepressants that we talked about, like Prozac and Tricyclic, were found to increase BDNF levels. So in all, we are maybe not moving away from the monoamine hypothesis, although ketamine, as my final example, doesn't really directly affect the monoamines, but it probably does in an indirect sense. I feel like serotonin, norepinephrine, and dopamine are like put on these pedestals when really they are just signaling molecules. They signal things, they communicate, and they're when you look at all the things that they do and in which areas of the brain they do them, I feel less like the neurotransmitters are having these effects, and I really think more about the receptors in the areas of the brain. Because serotonin is a great example of this. People like to talk about serotonin being the happy molecule, but it also makes you vomit, and it also makes you have suicidal ideation, and it also um can increase anxiety, and it can do all of these other things that are not really indicators that serotonin is bad, but just indicators that depending on what receptors it's binding to and depending on where it is in your brain, it might just do different things. And for that reason, it's almost like, I don't know. I feel like this gets a little too existential, but it's like, do the neurotransmitters even do anything? Or is it just the receptors and the anatomy? It's not, but it feels like that's the thing. You did it. This was my longest. I knew it would be. This was my longest lecture. It's usually like an hour and a half. There was so much for me to learn here. There was so much, and I hope you all learned some things. Drugs are cool. I just put PCP at the end here. Pound cake. Portable. I'm not as good at those as Curtis. But hail Yale.